Hey folks, and welcome to Advent of Code in F Sharp, day 10 already. Wow. I'm gonna put this up here so it generates a YouTube thumbnail for me without me having to do anything. But anyway, um, yesterday was a fun puzzle. It was the low point basin thing, and we used like a flood fill algorithm to solve it. But apparently, we over engineered it, or there was a faster solution. I just did the super generic thing where walls were not even taken into account. Well, turns out that if you look at the basins, for the example at least, let's maybe quickly drop to the browser. If you look at the basins for part 2, they are always walled off by edges of the grid or nines. So I was taking things one step at a time, growing the depth of the basin by one. So that would work if not every basin. Um, no, actually, it makes sense that they're walled off by nines because otherwise two basins would eventually connect into one big basin. But that was not supposed to happen. So if you know that every basin is walled off by nines, you can do it in a much faster way than the complex flood fill algorithm we have been using, or we used yesterday. But anyway, let bygones be bygones. It was still a very fun puzzle. Let's see what day 10 has for us in store in a couple of seconds. I'm really enjoying this year's Advent of Code again. Puzzles have been varied. I don't think we've seen the same kind of thing twice, and we're already in day 10, so that's promising. Let's take a look at the map. Here's we're still exploring the cave system here. We're still going exploring subnautical caves. If you like subnautical cave exploring, take a look at the video game called Subnautica. It's amazing. That's enough waffling. Let's take a look at day 10, syntax scoring. You ask the submarine to determine the best route out of the deep sea cave, but it only replies, syntax error in navigation subsystem online. All of them. I love it when my compiler says that. All of them? The damage is worse than you thought. You bring up a copy of the navigation subsystem, which is our puzzle input. Oh no, it's brain. The navigation subsystem syntax is made of several lines containing chunks. There are one or more chunks on each line, and chunks contain zero or more other chunks. Adjacent chunks are not separated by any delimiter. If one chunk stops, the next chunk, if any, can immediately start. Every chunk must open and close with one of 4 legal pairs of matching characters. I hate parsing nested parentheses. But okay, if a chunk's open with open parentheses, yep. So they have to be balanced and they have to be of the same type. This is a legal chunk that can contain no other chunks, or that contains no other chunks. Yes, there are more valid but more complex chunks. So you can have like a chunk containing a sequence of multiple chunks. You can nest different styles of chunks. Yeah. The whole shebang. This sounds like just doing a are these parentheses balanced problem. What is that called? Push down automata? Let's not dive into how we are gonna solve it. Let's maybe first read the entire thing. Some lines are incomplete. Oh no. But others are corrupted. Find and discard corrupted lines first. So looks like we're gonna do something easy and then we're gonna do something really, really hard again. A corrupted line is one where a chunk closes with the wrong character. That is, where the characters it opens and closes with do not form one of the 4 legal pairs listed above. Okay, what's corrupt about this? They don't match. What's corrupt about this? The outers don't match. Such a chunk can appear anywhere within a line. Okay, yeah, we're looking for corrupted. Or these are examples of corrupted chunks, and they can appear anywhere in a line. And then the entire line is corrupt as well. Yeah. Consider the following example. Yada yada yada. Some of the lines are not corrupted, just incomplete. I don't think I like that sentence. You can ignore these lines for now. Okay, so the difference between corrupt and complete is a corrupt line is balanced, but yeah, the type of parenthesis is wrong. So we have an opening close brace for every closing brace, but they're just of different types. Is that the difference? I think so. So we can ignore incomplete lines, which means when we parse, the parentheses are not balanced. Yep. The remaining 5 lines are corrupt. Oh, this is too much for my brain to handle right now. I'm going to trust this on its word. Stop at the first incorrect closing character on each corrupted line. Okay, so we are writing a basic syntax checker, and we just stop on every line on the first incorrect closing character. Do you know that syntax checkers actually have contests to see who can get the high score for syntax errors in a file? It's true. That's funny, actually. To calculate the syntax error score for a line, take the first illegal character on the line and look it up in the following table. To calculate the syntax error score for a line, yeah, okay, so first illegal character. Probably that's the first not matching type of a parentheses. We stop on the first one and we don't need to go further. And then we just map that to a number of points where one is not that bad and the other one is really, really bad. So we count up the illegal characters by these points. Find the first illegal character in each corrupted line of navigation subsystem. What is the total syntax error score for those errors? Okay, so 2 problems. First, we need to kind of detect corrupted lines. Or no, first we need to take a look at that incomplete thing, right? No, first we need to just do the corrupted part. That's supposedly the easiest part. Okay, some of the lines are not corrupted, just incomplete. You can just ignore these lines. This is what's worrying me, this sentence. I don't understand how this is supposed to make our lives easier. It looks like more work to filter out incomplete lines. Okay, but anyway, how do we get started on today's problem? I still have vivid nightmares of writing parsers for last year's Advent of Code. I went all the way last year and used a library called parsec, or at least fparsec, which is a parser combinator library for F#. Is there no examples? There has to be a better documentation. I know the documentation is sparse and you need to figure a whole lot out yourself. And it was a flashback to my college years where we talked about stuff like recursive descent, LL parsers, stuff like that. And this is exactly as complicated as that. I don't know if we want to go down this route just yet. Let's forget about that. It feels like it is a Friday though. It feels like day 10 should still be doable. So, strategy. Let's say we're parsing line by line, which is the approach we're going to have to take. And we just eat up character per character. What do we have to do? We need to keep track of every opening brace we encounter, because it has to be closed somewhere down the line. I have to keep track of the... We don't have to keep track of the position, actually. We just need to keep track of the first illegal character. First illegal character will always be a closing brace. Okay, yeah. So what if we go down a line, or we nibble up character by character, and for every opening brace we push that on a stack, and for every closing brace we encounter, it has to match the last element we saw on that stack. So let's give it a try on this first line. We nibble up this. That's all opening braces. Opening brace. So that's everything is on the stack. Then we nibble up this thing. That is the last element on the stack, so that can go. Stack still grows. Stack still grows. Stack shrinks. Grows. And this is the problem. Yeah? I think we might have an algorithm. Let's grab the example and let's give it a try, right? Still not sure about the incomplete thing. Maybe the incomplete thing is where everything is still balancing out, but we just reach the end of the line before we find corruption. Makes sense now that I think about it, it makes sense. This is the example. I'm also going to grab my input. That's not too bad. $49, that's a weird number of lines, but okay. Did I copy everything? Let's try that one more time. Yeah, 49. 94, sorry. It's early for me. So we need to first corrupt character, which is a wrong closing brace for every line. And that is optional because we just have some incomplete lines as well. That's like the outline in my head of what we're going to do. Now let's actually do it. Let's just start playing around with the example like we do every day. I'm typing like this is an automata, something I do automatically every day, but actually the problem is in the parsing today. So let's have our parser return an option, and if everything is cool or incomplete, we'll just say no problems here. If we encounter a corrupt character, we just return the corrupt character. So the return type actually is something in the lines of this. So it'll return a car option, yeah, an optional character. And I think the stack approach works. So we just recursively descend down line, not recursively, we just descend down the line string, and every time we see a opening brace, we put it on a stack. Every time we see a closing brace, we get it out of the stack. And a stack, I think, will match very well with the F-sharp list structure, because appending and destructuring it, or taking the first element, is a constant operation because it is a linked list. Yeah, that'll work. I needed some coffee for this. Okay, let's go. So let's match on line. So line has to be a list as well. Let's maybe do list of characters. So let's maybe do that first. So before we run our actual parser, let's do something else. Which makes a string into a list of characters. I think if we just map sequence to list over it, I think that should work. Let's see. Yeah, so this gives us an array of a list of characters. And then we need to parse, yeah. Okay, this should compile. Nope, that's not what I want to do. Do you compile? Yes, you do. Okay, so now we can pattern match on line as if it is a list. And in the case where we have nothing, we just return none, but that's an incomplete line. So this, let's put a comment here. And here we can do some actual magic. Yep. We also need a stack. So I'm just gonna write a recursive function. I'm gonna nest it in here. Yeah. So we don't have to give like empty arrays on the call side here. And we just can call the recursive function here. So I'm just gonna call it parse prime with a stack and a line. And that does the same thing, but now we have a stack. And we can call this parse prime function with an empty stack and the original line here. And yep, that all still compiles. Now we have recursion that's hidden from the, or where the accumulating variable is hidden from the outside world. It nice. But now, so we're solving this part. If it's an opening brace, we push it on the stack. If it's a closing brace, it has to be the first element of the stack, and we continue. Do I want to do it this way? Yeah, I want to do it this way. How many do we have? 1, 2, 3, 4 types? Yeah. I'm just gonna copy paste them. And put them here for the time being. So match with. Oh, come on. That's better. This is one. Yeah, I'm just gonna list all 4 cases. So let's do that this way. You have right angle brackets. I never know the names of these. When I'm pair programming or when I'm navigating in the mobbing session, something like that, it's always the brace, no the other type of brace. No, the squiggly kind of brace. Maybe I should learn these different names. But these are the 4 opening braces. If we encounter one of these, we nibble it up. So we continue parsing, but our stack grows with this new character. So we push X on the stack. And we have processed X, so we take a look at the rest. Yeah. That's it for the opening braces. And for the closing braces, we have to do the same, but well different. So we need to consume stuff on the stack. So let's write the closing brace. Now that I see this, we can do this with a when guard, and then we can put it on one line, but this is not too bad actually. So here we need to consume it here, or put stuff on the stack. Here we need to consume stuff on the stack. So what needs to happen here is there has to be, the last element on the stack has to be the opening bracket of the same type. So we can't do this for every case in the same way. I'm just gonna do this real quick. Maybe we'll clean that up later. But if we encounter a closing round parenthesis, then there has to be an open parenthesis on top of the stack. And then we're good. We are good, so then we continue with an element taken from the stack instead of adding something. So it's this SS thing I called it. And the string has been consumed by one character, so that moves as well. Yeah, and in all other cases, stack empty, different thing. Stack empty, that's a incomplete line, but so if we have something on the stack, we have our problem. We could show, what do we need to show? The character we expect or the character that is in there? We found 2 of those round. Yeah, so we need to return the actual character, not the expected character. So on the stack, that's the expected character. The actual character is this bad boy here. I think for one type of parentheses, this actually works. Maybe let's do the empty case explicitly. So we have nothing. And that's again incomplete question mark because I'm not sure. Is this correct what I'm seeing here? So the opening brackets, parentheses, I think, yeah. Closing parentheses. We need to look in the stack, yeah, and the last element has to be opening of the same type, yes. And then we can continue with the rest of the stack and the rest of the string, yeah. And if it is not the case, we have found a corruption. Or incomplete, but let's not take that into account. I think we might be, this might be the algorithm. I'm going to extract this into a teeny tiny function. What do we need for this to work? Let's maybe put that a bit lower. We put it in here. I think it has access to parse. Yeah. Access. It needs the rest of the elements. It needs the stack, and that's it. Okay, I'm gonna explicitly pipe all those things in because I have been burned on using outer scope variables in the past. So I'm gonna push in the stack and access and closing brace and the opening brace we expect. I think that's everything we need for that little function. This is madness, but okay. It takes a stack, it takes access, it takes a closing brace and an opening brace, which is the complement or the opposite one. So we pattern match on the stack, yeah. If it is the opening brace we expect, we parse as we were soldier, and otherwise, yeah, otherwise we found our first corrupted stuff, so we return that, and otherwise we say, okay, incomplete. So actually we need to call on closing brace with stack, access, closing brace, opening brace. Closing brace is something we should also be using. There we go. This can go. I think this is the first stab of the algorithm, so let's fill it in, fill it in, fill it in, and this is actually, yeah, let's keep it explicit. I was thinking maybe I replace this with an X, but that would make it more confusing, so let's not. This is this one, so opposite is this one. This is, where is it on my keyboard? The opening one is this one. If this works without crashing, I would be happy. And if we encounter something that is not a parenthesis, let's just crash with it. So we'll print out the unknown character, which will help our troubleshooting. So let's give this a try. This looks... so we have one of those, one, two of those, one, two of... Wait. Is this what we expect? Let's grab the example. So the first one we found this, yeah, and then we found a round parenthesis, yes, then a bracket, yes, then another round one, and then a closing beak, or whatchamacallit. This looks correct. I'm gonna use a choose instead of a parse, so we get rid of the option part. There we go. And now we just need to map this to the values, yeah. Grab it again. Totally not what I meant to do. Okay, there we go. Which was the first character? That's why it was crap. Failing on me. Just gonna write a quick lookup table with these things. So let points and the closing. This one is 3 points. And we have 3 more of those. So 1, 2, 3. This is 57. Are those all prime? And is this how they figure out the correct answer? Probably. But we don't care about that part. And we are not going to try to be very smart about stuff, so already forgotten. Nope. That's better. Do we have all of those different kinds of points? 3 yes, 57 yes, 1197 yes. I love the examples. They are almost always like they hit on every edge case and on everything. So if you make a typo in these points, for example, it's not too bad. The example will catch it. So this is our points lookup table, and now we just need to map whatever we get here to a point, right? Yeah, I think so. So for every corrupt character, look that up into points. Right? Can I get rid of the explicit variable name corrupt if I do this? No, I tried this yesterday. It's more readable this way. Anyway, so this should give us a sequence of numbers. It does. I will just sum that up. Two, 6, 3, 9, 7. That is correct. So let's do that on our input and hopefully not crash. So far, so good. So far, so very, very good. Cool. That's it for part 1. Let's take a look at part 2. And let's copy this file so I don't screw up my part 1. And not have to think about keeping part 1 working either. So part 1 is gone and out of our heads. Let's take a look at part 2. Now discard the corrupted lines. The remaining lines are incomplete. Incomplete lines do not have any incorrect characters. Instead, they're missing some closing characters at the end of the line. Yeah. To repair the navigation subsystem, you just need to figure out the sequence of closing characters that completes all open chunks in the line. You can only use closing characters. Oh no. Oh, that's more complicated than I thought. Wait, so you can only use different sequences of closing characters? 1, 2. There's no closing sequence for this. Yeah, there is, but then you also have this parenthesis. Okay, this is interesting. And you must add them in the correct order so that only legal pairs are formed and all chunks end up closed. Okay, in the example above, there are 5 incomplete lines. So first thing we have to do is throw away corrupt, and all the rest are incomplete. And we just try to complete the sequence by adding stuff from this set in the correct order. Autocomplete tools also have contests. I'm gonna look that up. That would be so cool. Yeah, that's just it. If you know about these autocomplete contests and these, what was it, syntax checker contests, hook me up with a link. I'm interested in learning more. But anyway, did you know that autocomplete tools also have contests? It's true. The score is determined by considering the complete string character by character. Okay, so first we complete the string, then we score it, multiply the total score by 5, and then increase the total score by the point value given for the character in the following table. Sorry? Oh, we take a look at the completion string only. So that's only closing braces. Okay, now I understand. We do need to figure out the different characters. Yes, because we increase the score by that point value. Okay, so the last completion string above will be scored as followed. That's for later. First, we need to figure out how to build those completion strings. Is that true what I'm saying? Do we need to do that? Let's take a look at those completion characters again. I'm thinking about a strategy already, and the thing we have to take a look at is like the parsed string up until now, the incomplete part. We are trying to close it, so the last character or the last opening bracket we encounter, so again the stack thing, that's the thing we have to close. And if it's a angle bracket or this squiggly bracket, that's easy. If you have to close a beak kind of bracket, that's a bit harder because we also close a rounded parenthesis. I don't understand why you would ever close using... Oh, okay, no. This is not the closing character. This is the closing character, probably. I'm making it more difficult again, am I? Yeah. These are not like chunks of length 1 or length 2. These are all just the closing braces. Oh, I'm glad I catched that before we dug into the code. Yeah. Oh, that would have hurt so much. Okay. This seems like a very solvable problem all of a sudden. It's just we parse our incomplete lines and we return our stack of currently open braces, yeah? And that we just reverse that. There we go. That is part 2. After we scored it. Right? Question mark? Yeah, I think so. Let's maybe take a look at the first example. No, it's too long for my brain to do this just in my head. I need to see it in code. So let's try the strategy. First we filter out the corrupt lines, which we know now. Then we have all the incomplete lines. And then we just do exactly the same thing. But instead of returning the first illegal character, we return the entire stack of still open parentheses. And we reverse that, and then we can start scoring, I think. Easy peasy, lemon squeezy. So let's go. I'm first going to take a look. Yeah, okay. So part 2 still works on example. Still gives us something reasonable. Yes. So let's first grab the... I'm going to rename this function. I'm going to call it is corrupt. And instead of returning the some none thing, I'm gonna return, yeah, you're corrupt. So this is corrupt. This is not corrupt, but incomplete. So this is where we have to do actual magic. Oh, you know what? Maybe we can do it in here as well. So instead of returning the closing brace on a corrupt line, we can... Are there only corrupt and incomplete lines? Are there complete lines as well? No, we only have corrupted or incomplete lines. We have no completed non-corrupt lines. So we can just invert what we do here. If we have a corrupt line, we say, I'm sorry. If we have an incomplete line, we return the stack, right? But do we return the... do we return the stack here, or did we already nibble something? No, we didn't nibble. Okay. Incomplete line. Here we return the stack again. And so we return an option of a stack, which is a car list. And it's not an is corrupt anymore, it's the find remaining opening braces. Something like this. So this function does kind of the same thing as our corrupt thing, but it works the other way around. For every incomplete line now, we get a remaining stack of braces, and for every corrupt line, we just get nothing. So if we use a choose, as we did here, it'll forget about those lines. Let's see that in action. So now we should get a list of a couple of open stacks, and it's really hard to parse this in my head. Oh no, it's just new line, new line, new line. Do we have only 3 incomplete lines? No. 1, 2, 3, 4, 5. Oh, actually, it is not new lining every element, is it? No. I'm gonna print those out really quickly to make sure that it looks correct. 1, 2, 3, 4, 5. Yeah, that looks better now. Or it's exactly the same, but now at least I can read it. So it should be a closing, 2 bracket or 2 squares. It looks okay, the first one. Maybe let's take a look at the last one. The only problem is we also need to consume the stack from left to right. So we just transform the stack to the counterpart. So this square bracket opening becomes the square bracket closing. That all works, yeah. So we just need to map every element in the stack to its complementary bracket. And then we can just start scoring. Cool. So let's do that. Array.map. Flip parentheses. So this just flips parentheses of one stack. Let's keep it in the array world. Is this an array? No, it's a list. Let's keep it in the list world. And it is a function mapping an opening brace of any kind to its counterpart closing. So something like this. Right. And we have 4 of these. Angle brackets. Squiggly thing. And a duck beak thing. If you know the official names of these brackets, please give me a shout. I think that will work to flip. Yeah, that'll work. I'm not too worried about this. Yeah, it flips. I got rid of it, but I want to see it again. This font size is a bit too small for my tastes, so probably also for you. There we go. Tack, 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 tack. That looks correct. So what do we do to score it now? The score is determined by considering the completion string character by character, which is what we have now. I wanted to rename this function to completion string. But my Visual Studio is being a kind of a bully right now, so let's forget about that. Stop messing with my code. Okay. Are we still good? Did it break stuff? I don't think it did. That still looks great. Yeah. Okay. So start by where were we? Start with a total score of 0. Then for each character, multiply the total score by 5. And then increase the total score by the point value given for the character in the following table. So we just do whatever we have times 5 plus score. Okay, makes sense. I'm going to do the exact same strategy. Let's build a lookup table containing these scores. So closing, this one is 1 point. Angle bracket is 2 points. Curly is 3. And the sharp one is 4. And that's a lookup table now. 1, 4, 2, 3. Yes, I am happy. So now we just need to transform our list of closing parentheses here into almost, not this, but we need to multiply by 5. Okay, let's get rid of this line. It's not what we want and it's only confusing me. Also this. Actually, we can map to scores first, right? Increase the total score by the point value given for the character in the following table. Yeah. So let's map these to scores first. Or let's write a score function. That sounds even better. So closing brackets. Let's look that up in the scores map. No. We need to multiply by 5 still, yeah? Yeah. So every line is like a sequence of characters. I was confusing myself. So we need to do something in the lines of a reduce or a fold, and every time we need to multiply by 5. Yeah. So let's use a fold from the get-go. Fold is a function that takes state and an element. So state is our current accumulating value. And we just need to multiply that accumulating value by 5 and then add whatever we find for this thing. Oh, and by the way, we start at 0. I think that's it. $294 for the last completion string sounds correct. And we have all the examples here. That looks good. Yeah, looks good. Let's go. I don't know what I did, but I didn't score. Oh no. Oh no. Negative numbers. Oh, sorry. We're not done yet. We need to find the middle score. Let's first make that into longs because we are overflowing the integer range. And I don't like overflow. So is this better? That is better. Let's drop back to the example so we can find the middle. Example. Yeah, it doesn't matter which way we sort because middle is middle. Is it something like this? Just take the element at the halfway point. So item instead of take will give us a single one. Let's call this scored because we already have a scores somewhere. And then we need to also do the middle part on scored, of course. What is it trying to do? Again, I'm taking the wrong things. Okay, so the middle one is, according to science, 288 something something. According to science, that is correct. So let's do this for our input now. We have a number. Will this be the correct number? I hope so. Cool. Knock on wood. This was a interesting puzzle again. And it didn't turn out to be that bad. I was having fever dreams about parsers already, but not today. Probably Eric Wassel is saving those for this weekend. Let's go over what we did today. We wrote a parser, a very basic parser that checks whether or not we have corrupt or incomplete lines in this beautiful brainfuck-like language. Or no, it's just a balanced parentheses language. I would not want to program in this language. I would definitely not want to debug in this language, but okay. And our challenge today was just writing a parser, or just, it's not an easy thing, but we had to write a parser. And for the first part, our parser had to just crash on the first corrupt character it encounters. So we're trying to balance opening closing braces of 4 different types here. That did not work for some lines, and we just need to figure out which characters were corrupt or which characters we did not expect. We use the parser strategy or parser algorithm that just pushes opening brackets on a stack, and every time we encounter a closing bracket, we nibble the top element of the stack, and they have to match or we are in one of those corrupt states. That's for part 1. For part 2, we had to go a bit further, so we had to take a look at the other set of numbers or lines, not the corrupt lines, but the other lines, which were incomplete. And we just reworked our function by flipping it, so every other case was an incomplete line, and that's where we returned the stack instead of the illegal character. And this stack just contained all the opening braces we have not closed yet. We just map that to their closing braces counterparts, and that's it. Loved today's exercise. I hope you did too. Let's see if we have some channel to raid here. If someone's still following. Yes, someone is still working. Let's go take a look at yes operator. Okay, we're gone in 5 seconds. Thanks for watching, and I'll see you tomorrow for Advent of Code in F#. Bye-bye.